Hey y'all, let's cover lesson 16, equivalent fractions. So this entire module, as well as exam 3, will only be on fractions, okay? And I know that even in college algebra and pre-calculus classes, folks are still struggling with fractions. So if we can get a good handle on it now, it will serve you for the rest of your life. The only way to learn how to do these and to get better at them is what I'm going to always say is practice, continue requesting more homework problems, similar problems in your MyOpen Math. All right. A number of the form A divided by B, where A and B are numbers, is called a fraction. Okay. The number A, which is always going to be the number in the top of the fraction, if that helps you, the number A, I'm going to put in the top, is called the numerator of the fraction, okay? While the number B, which is in the bottom, is called the denominator. Sounds like a Arnold Schwarzenegger movie. All right, two fractions are equivalent if they represent the same numeric value. They represent the same numeric value, but they might look different. It's not like they're wearing a hat or anything. They're just going to be different number values, and I'll show you what that means. All right. What fraction represents the shaded area of each of the following images? If you have a hard time seeing this, this is the part that is shaded of this two-dimensional item here. So we have what fraction is represented by each shaded? Well, the first thing you need to know is how many pieces there are. And there are a total of 3 pieces. So the total number of pieces, total number of equal pieces, that is going to be your denominator, okay? And there's 3. And the numerator in the top is going to be the shaded portion. And that is 1. 1 out of 3 is what that is representing. The next one, the total pieces we have of equal pieces, 1, 2, 3, 4, 5, 6. And how many are shaded? Just 2. These 2. All right, the next one we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total equal pieces. And 4 of those are shaded. Okay, but what you need to understand here is these shapes are all the exact same size. And the parts that are shaded are all the exact same size. So these 1/3, 2/6, and 4/12 are all equivalent fractions. They're all the same value, but they look different because it's using different numbers, all right? Based on how many total equal pieces you have. Right. How do these regions compare? What does that mean about the fractions that we identified? Well, the shaded regions are the same. The shaded regions are the same. The fractions are equivalent. The fractions are equivalent. And what that means is that 1/3 is equal to 2/6 is equal to 4/12. Alrighty. Are there ways that you can see to manipulate the fractions so that they contain the same numbers? Well, yeah, we could do that. All right, 4/12. We want to do that one. I could divide both of the numerator and denominator by 2. And when I do that, I get 2/6, which is this number. I could also take 4/12 and divide both numerator and denominator by 4. And with that, I get 1/3. So that shows that they're equal. Let's go with the next one, 2/6. 2/6, I can divide by 2 on both the numerator and the denominator. And that's 1/3. Another way to show things is 1/3. I can multiply both the numerator and the denominator by 2 and get 2/6. Now there's an unlimited number that I can do for the multiplication across. I can multiply by 3/3, 4/4, 5/5. You can just get crazy, but we're strictly staying within the numbers that we're dealing with here, these three. Also 1/3, you can multiply by 4 to get 4/12. And then the last one would be 2/6. We can multiply it by 2 over 2. And that gives us 4/12. All right. So the next one we're going to deal with is creating these equivalent fractions. So if you start with a fraction, then you multiply its numerator and denominator by the same number. The resulting fraction is equivalent to the original fraction. Symbolically, let's show what this looks like. So that means A divided by B. What we're doing is we're multiplying by a number, which divide by itself, so that creates it as 1. So A times C over B times C. This creates an equivalent fraction. To show you what that looks like with numbers, if we took the 1/3 and multiplied it by 2, A times C, 1 times 2 is 2, B times C, 3 times 2 is 6. These numbers have to be the same. They can't be different numbers. They have to be the exact same because 2 divided by 2 is 1. And that's the reason we can multiply anything by 1. So if you start with a fraction, then divide its numerator and denominator by the same number, then resulting fraction is equivalent to the original fraction. And here's what that looks like symbolically. A divided by B, I can just go, oh, there's another number, C, then I'm going to divide A by C and B divided by C. Numerically, that looks like 4 divided by 12. If I divided each of these, the numerator and the denominator by 4, I have to do it to both to keep them equivalent. 4 divided by 4 is 1. 12 divided by 4 is 3. Okay. If D and A are natural numbers, okay, natural numbers are the ones that start with 1, 1, 2, 3, 4, 5. Not 0, not any of the negatives. We say that D divides A if and only if, when A is divided by D, the remainder is 0. In this case, we say that D is a divisor of A. Okay, I understand. For example, when 36 is divided by 4, the remainder is 0. So if you take in your calculator and you put in 36, and you divide it by 4, all right, 36 divided by 4 is going to give you an exact number, 9. There's not going to be a decimal after it. Also, if you think about just knowing your multiplication tables, 36 divided by 4 is 9. There's no remainder. So the remainder is 0. So in this case, we say that 4 is a divisor of 36. On the other hand, when 25 is divided by 4, Houston, we have a problem. 25 divided by 4, well, 4 goes into 25 5 times. No, 6 times. 6 times 4 is 24. And when we subtract those, we just get a 1. This is called a remainder. All right. If we have a remainder, of anything, it's not divisible. So in this case, we say that 4 is not a divisor of 25. All right, so let's go with the definition here. Let A and B be natural numbers. The common divisors of A and B are natural numbers that divide both. Natural numbers that divide both A and B. All right. The greatest common divisor is the largest of the common divisors. It is the largest of the common divisors. And this is the GCD. GCD, greatest common divisor, is what you'll see a lot. All right. Find the greatest common divisor of 18 and 24. Well, we need to find the divisors first. Divisors of 18. And don't be stressing out about the language barrier. Math is a language. So if I'm saying words you don't understand, then that should be a note for you to say, okay, she's using a word. I need to understand it. That is part of the class. So you need to make sure you have the definition down. If you can't figure out a way to do that, talk to me and we'll get through it. Divisors of 18 are, well, always 1. 2 goes into 18. 3, 4 does not, 5, 6, 9. 9 times 2 is 18, and then 18 times 1 is 18. All right, let's look at the divisors of 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6, 2 times 8, 2 times 12, and 1 times 24. And then the common divisors are what? Well, what do they have in common? 1, 2, 3, 6, and that's it. All right. So common divisors are 1, 2, 3, and 6. So what is the greatest? The greatest common divisor? Common divisor. So out of all of these 1, 2, 3, and 6, which one's largest? 6. So 6 is our greatest common divisor. Okay. A fraction is said to be reduced to lower terms if the greatest common divisor, if the GCD of the numerator and denominator of the numerator is the top, numerator, and denominator is the bottom of the fraction, and denominator is 1. Okay. Or they have no common divisor. Or they have no common divisor. Have no common divisor other than 1 in itself. Other than 1. All right. Let's go for an example. 2/3 is reduced to the lowest terms because the greatest common divisor of 2 and 3 is, well, 2 and 1 would be the divisors of 2, and 3 and 1 are the divisors of 3. So the largest would be 1. Okay. On the other hand, 4/6 is not reduced to the lower terms because the greatest common divisor of 4 and 6 is what? Well, you would do the same thing. Divisors of 4, divisors of 6. And 4 would be 1, 2, and 4. 6 would be 1, 2, 3, and 6. They have 2 in common, so 2. You would have to do your divisors if you don't know what goes into both of them. Reduce the fraction 18 divided by 24. Well, we've already
found the divisors for 18 and 24. So all we have to do now is use the greatest common divisor, 6, and divide both of those numbers by 6. So 18 divided by 24, we've got the divisors of it. We found the common divisors, and then we found the greatest common divisor. And so that means I can divide 18 by 6 and 24 by 6, and I'll be at my lowest term. 18 divided by 6 is 3. 24 divided by 6 is 4. All right, so this is the greatest common divisor. There's another way we could have done this without using the greatest common divisor. All right, so what if you didn't go through the process of finding your greatest common divisor? What if you just willy-nilly it and went just like 18 and 24, they're both even. I know they're both divisible by 2. Whoop, whoop. So let's do that. 18 divided by 24. I'm going to divide both by 2 because they're both even numbers, so I know they're both divisible by 2. 18 divided by 2 is 9. 24 divided by 2 is 12. Cool. Hold the phone. These are both divisible by 3. 3 is made up of, 9 is made up of 3 times 3, and 12 is made up of 3 times 4. So now I can divide both by 3. This just seems like a lot more work. 9 divided by 3 is 3, and 12 divided by 3 is 4. Please note they have the same answers. One, we got there a little bit faster. The words factor and divisor are equivalent and used interchangeably. All right. Cancellation rule. If you express the numerator and the denominator each as a product, then you may have cancel common factors from the numerator and denominator. So if you express the numerator and denominator each as a product, remember what product is? You need to have your math language dictionary. Product is always multiplication. All right. These are the result is then going to be an equivalent fraction. All right, we're going to reduce 28 divided by 35 to the lowest terms. Well, I'm going to do it like this. I'm going to take 28 and find out, I'm going to break it down to its prime numbers, as low as I can take it. 28 is right off the bat 4 times 7. And then 4 is 2 times 2. So the factors are 2, 2, and 7 for 28. Now I'm going to look at 35. Just creating a little tree here. 35, you can create 2 multiplications. It doesn't matter which ones you start with. Is just 5 and 7. And that's as low as they're going to go. All right. So what are how do I want to do this? I want to show you another way you can do this. So if you have 28 over 35 is equal to 2 times 2 times 7. 2 times 2 times 7 over 5 times 7. 5 times 7. What we were just speaking about, or what I was just speaking about in that definition, is you may cancel common factors from the numerator and denominator, right? They have to be the exact same number. So do we have anything in the numerator that's also in the denominator? We have 7. 7 divided by 7 is 1. So therefore I can cancel these 2 out. And I'm left with 2 times 2, which is 4, over 5. Okay. All right. The next one. 14 divided by 42. Well, I'm going to come over here and do the factors of 14 and 42. Highly suggest at this point that you pause the video and attempt to do this entire next one on your own and then come back and let's do it together. So if you're back, welcome back. 14 breaks down into 2 and 7. That's as low as it's going to go. And then 42, I'm thinking of 2 and 21. 2 is a prime, so 21 breaks down into 3 times 7. And those are both prime. So 14 over 42. 14 is 2 times 7. 42 is 2 times 3 times 7. I can cross out the 2's. I can cross out the 7's. Okay. Be careful. This is where people really mess up. A lot of people will just write that the answer is 3, and they would be wrong. Okay. So if you cross out everything in the top, the numerator, or if you cross out everything in the denominator, then that becomes 1. So in the numerator, since everything else has been crossed out, we now have 1 divided by, and all we have left down here is 3. All right. So if all factors cancel in the numerator or in the denominator, you're going to put a 1. So if all factors cancel, then you're going to put a 1. Okay, let's go to the next one. Reduce the following to lowest terms. Okay, try this one yourself. This would be a good one for you to try. Focus on just the numbers first and then the letters. All right, 56 and 60. Let's break these down, see what they're made of. So 56 is 7 times 8, 7's prime. 8 is 4 times 2, 2's prime. And 4 is 2 times 2. There you go. 60 is, I'm going to think of 6 and 10. 6 is 3 and 2, that's prime. And 10 is 5 and 2, those are prime as well. All right, so in my numerator, I've got 2 times 2 times 2 times 7. 2 times 2 times 2 times 7. All right, I've got 2 x's, x times x, and 1 y, over. My numbers are 2 times 2 times 3 times 5. 2 times 2 times 3 times 5. I've got 1 x and I've got 2 y's. All right, let's start crossing things out. These 2's are gone. These 2's are gone. No 3's crossing. There's no 5's or 7's crossing. This x is gone. These y's are gone. So we're left with 2 times 7 times x over 3 times 5 times y. And that equals 14x over 15y. All right. Express 3/5 of an equivalent fraction having a denominator of 20. All right. Well, 3/5, and they want me to have a denominator of 20. So the only thing that's going to change here is my 5. How does 5 become 20? Well, you have to multiply 4 by 5 to get 20. What you do to the bottom, you have to do to the top. 3 times 4 is 12. Attempt this next one yourself. Express 8 as an equivalent fraction having denominator 5. This one's tricky. Maybe we should work through this one together. So if you have 8 and you want to have a denominator of 5, what is the denominator for 8 right now? Well, that's the first thing you need to understand. And if you have a whole number here, the denominator is always 1. All right. So how do we get 1 to become 5? And we can't add or subtract. It's got to be multiplication or division. Those are your only 2 options. So 1 times 5 is 5. What we do to the bottom, we have to do to the top. 8 times 5 is 40. All right. Now, even this one's more fun. Oh my gosh, I love this stuff. This is so fun. So we're going to express 2/9 as an equivalent fraction having a denominator of 18a. Too much fun. We want it to be 18a. Okay. How does 9 become 18a? Well, it needs to have an a in there that it's multiplied by. but it needs another number as well. 9 times 2 is 18. So 9 times 2a would give us 18a. Again, what we do to the bottom, we have to do to the top. 2 times 2 is 4a. There we go. All right. Last page on this one. Note on negative fractions. Okay. 3 divided by -5. Here's something neat. I like to show my college algebra students. Is this equivalent to this equivalent to this? Are they all the same or are they different? They're all the same. They're all the same fraction. So they can all be written as -3/5, which is the better way to represent them. Okay, this is just the better option. Having a negative in the denominator is kind of wonky for people. All right, so let A and B be any integers. All 3 of the following fractions are equivalent. Okay, well, -a divided by b is equal to -a divided by b is equivalent to a divided by -b. So what I wrote up here is correct. They are all equal. All right. The next one says to reduce. We have 50x cubed divided by -75x to the 5th. This would be a great one for you to attempt on your own. The only thing different that we're dealing with here is a positive and a negative. And we already know that a positive in the numerator and a negative in the denominator is going to make the whole thing negative. So that's going to be a non-issue. Let's find out what the factors of 50 are and 75. 5 and 10 for 50. 5's prime. 10 is made up of 2 and 5. Those are prime. 75, I'm thinking 25 and 3. 3's prime. 25 is 5 and 5. Please note these are all multiplied. So in the numerator, I'm going to have 2 times 5 times 5 times 5 times 5, and then 3 x's, 2, 3, over. I'm going to keep my negative. 75 is 3 times 5 times 5 times 5 times 5, and then 5 x's, 2, 3, 4, 5. All right, let's cross things out. I've got 2. I'm going to bring that negative up front here. 3. 5's are gone. 2 of the x's are gone. I'm left with, 3 of the x's are gone. And I'm left with x times x. So this is -2 over 3x squared. Is my answer. When you're putting this into MyOpenMath, you would write this as, and you got to be really careful because many of you are going to want to say, okay, -2 divided by, and then you'll say 3x squared. The problem with this is that the computer, just like a calculator, is going to read this as -2/3 x squared. So they would see this as -2/3 x squared. They don't see the x squared in the denominator like it's supposed to. In order for MyOpenMath or your calculator to see that, you have to put parentheses around everything that goes in the denominator. Okay, be very careful with that. All right, next is let A and B be any integers. Then -a divided by -b is just positive a divided by b. Anything divided by negative divided by negative is the same thing as a negative times the negative, and it makes it a positive. When the signs are the same, it's positive. So now we're going to reduce -12 xy squared divided by -18 x squared y. Please pause the video and attempt this one yourself, and then come back and check to see how you did. This is a great way to learn. All right, I'm going to take my factors of 12 and 18. 12 I'm going to think of as 4 and 3. 3 is prime. 4 is 2 and 2, and those are prime. 18, I'm thinking 2 and 9. 2 is prime, and 9 is 3 and 3, and those are prime. All right, so this is equal to, negative divided by negative, signs are the same, so it's positive. I'm not going to deal with these negative signs. I'm done with those right now. So they're gone. The 12 is made up of 2 times 2 times 3, an x, and then we have 2 y's up there. The denominator has 18, which is 2 times 3 times 3, 2 x's, and a y. All right, let's cross some stuff out. And an x is gone and a y is gone. So we were left with 2 times y in the numerator and 3 times x in the denominator. Final answer is 2y over 3x. Again, when you're putting this into MyOpenMath, do not just put 2y divided by 3x. The MyOpenMath is going to see that as 2y divided by 3x. That's what that looks like. You don't want to do that. You want it to look like this. So it's going to have to be parenthesis 2y divided by, close parenthesis, divided by parenthesis 3x. And this will provide you that answer in MyOpenMath. Be very careful, okay? All right, that's it for this lecture. Let me know what questions you have.